Hello everyone. Am I audible?
Yes, ma'am. Good evening, ma'am.
Yeah, good evening. So this is your session for solving the mock for n-term. Have you all tried solving the questions of mock? Yes, no?
Yes,
Okay. Have you all prepared for your n-term exam?
yes, ma'am.
Okay.
Yes, sir.
Okay. So I will share my screen now and we'll start solving the questions. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So the first question of this mock is, let x be a discrete random variable having the following probability mass function. Okay, where x is taking the value 0, 1, and 2. So find the value of k. Okay, so you can see this PMF is given to us and the values taken by x is also given. We have to find the value of this constant k. So how will you solve this question? What will be
Putting
the
the
approach?
value by putting
Okay,
the value 0, 1, and 2, and their sum of their probability equals to 1.
yes, so we have to use the property of PMF, that summation of the probabilities, okay, for all the values taken by x should be equal to 1. Okay, so the PMF function, so we have to use the property that summation of all the properties, okay, for all the values of x, this should be equal to 1. Okay, so here x is taking values from 0 to 0, 1, and 2. Okay, and the function is k, and then 3cx divided by 3c, 3 minus x. So this should be equal to 1. Now we can put the values of x. Okay, so it will be k 3c0 divided by 3c 3 minus 0 will be 3, then k 3c1 3c 3 minus 1 will be 2, and then k 3c2 divided by 3c 3 minus 2 will be 1. Okay, now we can take k as common. So now what will be the value of 3c0?
1.
It is 1, and 3c3
1.
1.
1,
Okay, then 3c1
3.
3.
3,
3, 3c2 this will also be 3,
Yes, ma'am.
3c2 is 3, and 3c1 is 3. Okay, so now this will be 1, this is also 1, plus 1 equals to 1. So value of k will be equal to 1 by 3. Okay, 1 by 3, which means 0.33. Okay, is this question clear to everyone?
Yes, ma'am.
yes, ma'am.
Okay. Okay, then the second question. Which of the following variable are numerical? So height, Aadhaar card number, PAN card number, passenger name reservation, PNR number, and then stopwatch time in seconds and PIN code. So what all are here the numerical variable, and what are categorical? Tell me.
Numerical variables are height and the stopwatch time.
Yes. Okay. So height and stopwatch time will be numerical variable, and the other Aadhaar card number, PAN card number, they are categorical variable. Okay. So they have numbers in them, but they are for categorizing. Okay. They don't have an actual numerical meaning. Okay. Is this clear to
And
everyone?
which order they follow as a categorical variable? Aadhaar card number, PAN card.
Aadhaar card. Okay. You tell what should be Aadhaar card number, ordinal or nominal? Anyone?
I guess
It will be
nominal.
Yeah, it will be nominal
Nominal.
because we cannot compare the Aadhaar card numbers, right? You cannot say
Okay.
that this Aadhaar card number is greater than the other one. Okay. So they are just like labeling the different peoples. Okay. Similarly, PAN card number is also nominal. PNR number will also be nominal. Okay. PIN code will also be nominal. Okay. Because you cannot
जी.
compare in them. Okay. Yeah. So all the other are categorical and nominal variable. Height and stopwatch are numerical variable.
Ma'am, but in case of Aadhaar card or PNR number,
Hmm.
because say for example PNR number, like the second passenger to me, he can have just a difference of one of the PNR number. So can I say it is ordinal?
No, no, it will not be ordinal. How it can be nominal? Oh, sorry, how it can be ordinal?
I think we can order the PNR numbers of the passengers. They
But
make a meaningful order.
okay, you are saying that you are arranging them, but you cannot say that suppose some Aadhaar, I'm just writing any number, suppose Aadhaar card number or PAN card number. Uh, Aadhaar card number looks like this. Suppose this. Okay, suppose this is a Aadhaar card number. So now this is one number. Okay, now you are trying to arrange it like this. That suppose this is. Okay, so you are saying that you can arrange like this, right?
Yes.
All the other values are same. This is 20 and this is 21. So this number is greater than this one. Okay. But how like you are it this number has no numerical meaning. Okay. It is just for
Ma'am,
labeling. Yeah, okay, suppose
words arranged in dictionary, are they ordinal or nominal?
they are also nominal.
Okay,
Okay.
got it.
Yeah. So suppose in a class there are 50 students. Okay. Rule number 1, 2, 3, 4, 5. Okay. In this way, you have suppose 50 students in a class. Okay. So you are arranging them that is okay, but they don't have any like you cannot say that rule number 1 is less than rule number 2. Can we compare like this? No, right?
No, ma'am.
Okay. So you are arranging them, that is a different thing, but they don't have any numerical meaning. Okay. So you cannot
Got
compare
it.
those things. Okay. Yeah.
Got
Ma'am,
it,
we
ma'am.
can say that it is a unique identity for each person. So no need to
Yes, yes.
rank.
Yes, yes. Correct.
Thank you, ma'am. Got it.
Okay, yeah. Okay, so here in the question number 2, height, okay, and stopwatch time. These two are numerical variables. Okay, then the next question is the variance of a binomial random variable x is plotted against varying values of p with n kept constant. It is observed that the maximum value of variance is 40. Then what is the value of n? So tell me, how will you solve this question? So first of all, here we have variable x, which is a binomial random variable. Okay.
Excuse me, ma'am.
Hmm.
Ma'am, can I get a YouTube link for this recording, ma'am?
Yes, yes, chat will be there in the calendar.
Okay, ma'am. Actually, ma'am, maths 2 class right now.
Okay. Okay, you will get the link.
So,
Yeah.
ma'am, I can.
Hello.
Ma'am, thank.
Okay. Yeah. So x is following a binomial distribution, and the parameters are n, comma p. Okay. And then it is saying, so the variance of binomial random variable x is plotted against varying values of p and n, kept constant. So we are varying the values of p and n is a constant number. Okay. So it is observed that the maximum value of variance is 40. So tell me when you will get the maximum value of variance.
For P
P
is
is
equal
1
to
by
2.
2.
Yeah, correct. Okay, so first of all, the variance formula, variance of x here is np 1 minus p. Okay, so this value will be maximum when, okay, this will be maximum when p is equals to 0.5 or 1 by 2. Okay, is this thing clear to everyone?
Yes,
Okay,
ma'am.
if you want to test this thing, you can just take any other value of p. So p lies between 0 to 1. Okay, we all know that p is the probability, so it lies between 0 to 1. You can try for any other value of p and just see on which value you will get the maximum value of variance. Okay, so you will observe that for p equals to 0.5, this value is maximum. Okay, so now the maximum variance is given to us, which is 40. Okay, so np 1 minus p, this is equals to 40. This is given to us. Okay, also p should be 0.5. Okay, for this to be maximum. So n into this is 1 by 2, and this will also be 1 by 2, and this is 40. So what will be the value value of n from here?
160.
160.
160. Okay. Is this question clear to everyone?
Yeah.
Yes, ma'am.
Okay. Okay, then the next question is, if the median of the data set xi, where I is going from 1, 2, 3 up to n, is 15. So what is the median of the data set 2xi minus 2? Okay, where I is also 1 to n. Okay, so tell me, how will you solve this question?
Ma'am,
Can
first we have
just
to multiply
multiply
the
2
median
to
into
the
2
median of the
and
data set and then add
2 into
and then
15
subtract
minus
2.
2.
Yes, correct. So median of this data set xi. So x1, x2 up to xn. Okay. So median for this, okay, median for this is suppose some number, suppose m. Okay. Then we have to find the median for the data set 2x1 minus 2, 2x2 minus 2, 2x3 minus 2, like this, 2xn minus 2. So in this case, what will be the median? So median will be, we have to multiply it with 2, okay, and then subtract 2. Okay, so the median for this data set, okay, this is given as 15. Okay, this value is 15. So this will be simply 15 into 2 minus 2. Okay, so that will be 30 minus 2, which is 28. Okay, is this clear to everyone?
yes, ma'am.
Okay, then the next question. So an entrepreneur has invested in 4 startups. In the startup, if the startup makes profit, it will yield respective profits of 20, 25, 30, and 40 in units of lakh. On the other hand, for each startup, the entrepreneur may not get profit and he will incur a loss of 10 lakhs, okay, 10 in units of lakh. So if the probabilities that the entrepreneur will make profits from these startups are these respectively. So what is the expected total profit? Okay, and a negative profit indicates loss. So what should be the approach to solve the question?
0 point.
So here we have to find the expected total profit. So total profit, which means from all the 4 startups, what profit we are getting, that expected value we have to calculate. Okay. So first of all, we will calculate the expected profit from all these 4 startups. Okay, and then we will add those values, and that will give you the total expected profit. Okay. Yes,
Uh,
anyone have a question? Yes.
yeah, actually, we'll do that E is equals to P concept, which is for Bernoulli. Yeah, we'll add up all the probabilities to we'll add that all probability for the expected total profit of probability.
Okay, I will solve this question and you can match. Okay.
So
Okay,
zero.
so
My question is, if we will like 0.1 is the first probability, so we will multiply this value to 20 and then 0.3 to 25. Is that the approach we should apply for
okay,
this type of questions?
okay, you are getting it, but not entirely correct. So see, we have to find the profit for each startup. Okay, so for the first startup, you can see the profit is 20 and the probability for getting this profit is 0.1. Okay, so this is the profit for first startup. What is the loss for the first startup and what is the probability for that? Can you tell me?
Probability is 0.1 and the loss is 10. Yeah, it is 10.
0.9.
So 1 minus 10 it will be 0.9
Yeah, so 0.9 will be probability of loss.
loss.
Okay, yeah, so that is correct. So in this way, you will calculate the expected value of expected value of profit for the first startup. Okay, so you can see the profit value and the loss value is given, and the value of probability for profit is also given. So 1 minus this value, okay, this probability will give you the probability for loss. Okay, so now I will show you how to solve this thing.
So, ma'am, these are 4 independent Bernoulli random variables.
Yes.
Calculate for each. Okay.
Okay. Okay, I will not say Bernoulli because the values are not 0 and 1 here. Okay.
Okay. Got it. But 4 independent.
Yeah, the values the values taken by x and the probabilities are given. Okay, so you can find the expected value. So for startup number 1, okay, so the profit is 20 lakhs, okay, and the probability is
0.1 of getting success and 0.9 of failure.
so loss is 10.
Minus 0.9.
Yeah, so this will be 0.9. So if you want if you want to represent it like x1, okay, so x1 will be, so it is taking values 20 and 10, okay, and the probabilities are
minus 10.
yeah, sorry, it will be minus 10 because it is a loss. Okay, so this will be 0.1 and the loss is, this probability is 0.9. So this you can say that the distribution of random variable x1. Okay, and now you have to find the expectation of x1. Okay, so this will be 20 into 0.1, okay, minus 10 into 0.9. Okay, because this is a loss value, so we will take it as negative.
Minus 7.
2 minus 9.
So this is minus 7. Okay, so we can conclude from here that for the first startup, the expected total profit is minus 7, which is actually the loss of 7 lakh rupees. Okay, so similarly, we have to find for all the 4 startups. Okay, so profit is, so this is 25 and the probability is 0.3. And loss is 10 and the probability will be 1 minus 0.3, which is 0.7. Okay. So expectation of x2. Okay, x2 is for second startup. So this will be 25 into 0.3 minus 10 into 0.7. Okay, so this will be 0.5. Okay. Then for startup number 3,
30 into 0.2. Profit 30. Probability 0.2.
okay. So loss is 10 and this probability
0.8.
will be
0.8.
Yeah.
8.
Yeah, so expectation of x3. Okay, is this clear?
Is
What is
30.
x3?
Yeah, that
Yes.
is clear.
Okay. Yeah. And then this will be 10 into 0.8
8.
minus 2. Okay.
Forty. 0.1 probability.
Okay. So this is startup 4. So this will be 40 into 0.1 minus 10 into 0.9. Okay. So this will be 4 minus 9 minus 5. Okay. So now we have to find the total expected profit.
So we'll add all the values, right?
Yes, yes. Okay. So this is okay. Now just put all the values. So this is minus 7, 0.5, and then
Minus 2.
minus
Minus
2,
minus 5.
okay, so this will be minus 13.5. Okay, just check the answer. Okay, so minus 13.5 is the total expected profit from all the startups. Is this question clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, then the next question is, if the graph of PMF of a binomial random variable of n is equals to 10 is exactly symmetric about x is equals to 5, then the value of p could be. So yeah, tell me, how will you solve this question?
For symmetric, P should be 0.5.
Yeah, this is the answer. So you can see that it is given that the graph of this variable, okay, these values are given, but actually we don't have to use these values. Okay, the only thing we have to notice here that the graph is symmetric. Okay, it is not a skewed graph. Okay, it is symmetric. So for symmetricity, okay, the value of p should be equal to 0.5.
Yes, sir.
Okay, is
Ma'am,
this
it will be 0.5 because it
yeah, so simply it will be
5 would be average, right?
yes, this is the average
And
value.
so n is equals to 10, so it will be 0.5.
Ma'am, can we say expectation of x equal to n into p? So
Yeah,
expectation of
sorry.
x is,
Yeah, expectation of x will be n into p, not 5. Sorry.
yeah. So expectation of x is, I think, given 5 at 5, and then n into p, I think 10 into p, we get the same answer, 0.5.
Yes, that is also fine.
Yeah, X is given for the average value, right? Because it is given in the respective of graph. So in the graph, if the symmetry is it is symmetric, then the value is average.
1 minute. So if you know the properties of binomial random variable, binomial distribution. So the thing is, if the value of p, if p is less than 0.5, okay, then it is right skewed.
Yes, ma'am.
Okay. If p is equals to 0.5, then it is symmetric. Okay. And if p is greater than 0.5, then it is left skewed. So you have to remember these properties. From here, you can conclude that if the graph is symmetric, okay, the
Ma'am, I
value of
think
p
it
should
is.
be,
Ma'am, I think it is reversed. Like if the value is greater than 0.5, it will be left skewed. And it is, yeah. And if it is less than 0.5, it is right skewed.
yeah, if it is less than 0.5, then it is right skewed. Okay, that's what I have written.
It is
Okay,
correct. Less than 0.5 is right skewed.
yeah, p is less than 0.5, that will
Yes.
be right skewed. Okay,
Yes.
so from here, you can conclude that if p is 0.5, then the graph will be symmetric. Or if you are getting a symmetric graph, then the value of p should be 0.5. Okay, you can say it both the ways.
Ma'am, is this true for all distribution?
This condition, this property is for binomial distribution, not for all.
Okay, ma'am.
Yeah. Okay, so for this question number 6, the answer will be 0.5. Okay, is this clear to everyone now?
Ma'am, just a basic question. So, like,
Hmm.
if the number of n increases, it will still be symmetric, right?
Yes, yes.
So there is no point of like it is just to confuse us for mentioning that n is equals to 10. Like there is no
Yes.
in this question, right?
Hmm.
Okay, okay.
One
Got
more
it,
thing
ma'am.
is there that if you increase this value of n, okay, if you increase the value of n, as n increases, then the graph tends to be symmetric. This is one more thing. If you have studied the properties in the lecture, if you increase the value of n, okay, then no matter what is the value of p, the graph tends to be normal. Okay, so it tends to be symmetric if you increase the value of n. Okay, then even if the value of p is something else, okay, suppose it is 0.8 and n is equals to suppose 50. Okay, then
Ma'am, if
also
the
this would be
value,
symmetric.
yeah, I have a doubt.
So here you
If the
can see,
value, if the value would be like 0.2 or 0.3, then it is also would be symmetric. If we increase the value of n.
if the value of p is,
If the value of p is 0.2 or
if you increase the
0.3
value of n,
and yeah, and then
hmm,
we increase the value of n, the graph would be symmetric.
yes, yes. If you keep increasing the value of n, then this tends to be symmetric. This bell-shaped curve you will get. Okay, and if you are having a small number of n, okay, suppose 10, suppose n equals to 5, like this. Okay, so then it depends on the value of p. Okay, then you have to, in that case, you have to consider these situations, these three conditions. Okay, if you have
Okay.
larger value of n, then it will be symmetric. Okay, so here your answer is p is equals to 0.5 as we have a small value of n. Okay.
Ma'am, is it
Ma'am, the value of x can be anything, no, ma'am, in this scenario.
Yes, yes.
ma'am, if we increase the value of n, it is like that, na? Hypergeometric tends to binomial. That is the main concept, no?
Okay, the thing here is this
And
happens because of the central limit theorem. Central limit theorem you will study in the stats too. So in that case, you will see that when you increase the number of, if you increase this n, okay, then binomial distribution tends to be normal distribution. Okay, it has the property of normal distribution if you increase the value of n in the binomial distribution.
no, ma'am, as we studied in hypergeometric, like n minus n upon n minus 1, where we increase the capital N to the infinity, then that will become 1 and it will behave like a binomial. It is the same property or it is a different property?
That
The
is, I
value.
think, different, or I have to check that. I'm not sure about that right now.
Okay.
But this is the reason, yeah. Okay. As you keep increasing the n, then binomial distribution tends to be normal distribution. Okay, it tends to behave like that. Okay, any other question? Okay, then the next question is, a robber who needs to open a lock of a house has 21 keys, out of which only one key can unlock the house. The chance of selecting a key is equally likely for all the keys. Okay, and the robber will not use the key that did not open the lock in the upcoming trials. So let X be defined as the number of trials robber requires to open the house. What is the value of expectation of X? So tell me what should be the distribution of X here. Okay, we have to find the value of expectation of X. Okay, for which we require the values of X and the corresponding probabilities, right?
Ma'am, it is discrete uniform random variable.
Yes, correct. So it is discrete uniform, and so you can see that 1, 2, 3 up to n is something in we see in the discrete uniform. So what is this n here?
21.
21.
N would be 21.
Yeah. So we have 21 different keys. Okay. So we can write it like this. So X is the number of trials.
Excuse me, ma'am.
Trials. Hmm.
Ma'am, here they've mentioned that is not going to use the key again, if at all, like the next time. So
Yes.
wouldn't that affect the probability?
Yes, it will affect, because in that case, the distribution of X might change.
Yeah.
Yeah. So here X is taking values from 1, 2, 3, and up to 21. Okay. And the probabilities will be, what will be the probabilities?
1 by n.
1 by
1 by
21.
21.
Yeah, so 1 by 21.
Ma'am, here, I mean, what I asked was, in this case, this probability wouldn't it affect because he will not be choosing the next key again? Or
Yes,
is
yes.
it like it is for the trial and the probability that he is not he's not choosing the same key again, would it affect the probability of being correct? And here this is the probability for trial, so I'm getting confused between both of it.
Okay, see, the question is, he has 21 keys and only one key can unlock the house. Okay, so the variable X is taking values 1 to 21, suppose. Okay, for different keys, we are giving the numbers 1 to 21, and then they are equally likely. So equally likely to be taken, and they are independent also. Okay, the second line is, the robber will use the key that did not open the lock in the upcoming trial. Okay, so which means once the key is used, it will not be reused again. Okay. So if this criteria is not given, then the probabilities might change, I think.
I think the denominator it will decrease by 1 if I take like
Yes, in
uh
that case, the probability will change.
yeah, so the second key opening will be 1 by 20, I think. Because the first key is not opening, only then I'll go to the second.
Yeah, that can be different. It will not be same as this. And then what will be the probability? That will depend on the situation, the condition which will be given in the question.
But ma'am, previously it
Ma'am,
states that the
is
selecting the
that
key is equally likely. Means each time we can select a key which can open a door is equal to in every step. So probability of opening door will be always the same because it is a equally likely
do
event.
do we have to use,
No,
ma'am,
probability
do
will
we
not be
have to
same
use
because
21C1? Like we can use 21C1 for this?
21C1 for what? Choosing the key.
Yeah, for choosing the key.
Okay, 1 minute.
Ma'am, but how can we use 21C1? Because here we know there is one which is the correct key, and we have to just do by the trials as given in the question.
Yes, yes. Yes, so we don't need to do 21C1 actually.
Ma'am, every time
Because we are because
we use one key, we discard that key. That is the 21C1, like 1 comma 21 into 1 comma 20. That is the
But
we
that is the
discard that.
trial. So there is no need of doing combination concept here, I think.
yes, we don't need to do that, I think. Okay, so I will check if there is any other method also to solve this question, but
if it is opening in first trial, then we'll take x is equal to 1, then the probability will be 1 by 21. And if it is opening in the two trials, then in the first trial it got failed, so it will be 20 by 21 into 1 by 20. So we always get back 1 by 21 probability.
yes, so actually those things are there. You all are saying the correct things. The thing is, what condition is given in the question, according to that, we have to proceed. Okay, this is the main thing. So here in this particular question, it is given that that selecting the key is equally likely, and this condition is also given. So this approach will be true. Okay. What can be the other approach to solve this question? I will check. And you can also check what can be the other approaches to solve this question. But as of now, I am solving it by this method. Yes.
Ma'am, this will be the case of hypergeometric, right?
This is not hypergeometric in this case if it is given already that it is equally likely.
Okay.
Here it will not be hypergeometric. Okay, I will consider all your queries. I will see, I will look into that. But okay, as of now, you solve it by using this method. Okay. So x is here is uniform, and we have to find the expectation of x. Okay. So do you remember the formula? What will be the expectation of x here? Or you want to solve it?
n plus 1.
Yeah, so the formula is n plus 1 by 2. So this will be 21 plus 1 divided by 2. So this will be equal to 11. Okay. If you don't remember, you can just use the formula of expectation. And then it will be 1 into 1 by 21 plus 2 into 1 by 21 like this. Okay.
Ma'am, can you once again explain how we are getting just 1 by 21 in all the trials?
Because they all are equally likely to be selected. Okay. So the probability for each of the values will be same. Okay. Or if you want to
No, that
find that.
But what I did when I was solving the question was for the first trial it's 1 by 21, and in the next trial for the first attempt he selected a wrong key. So that probability also I considered, and then the corrected one. So that's why I thought that it's the case of hypergeometric.
But the question it doesn't asking
No.
in which event you will unlock the door.
Yes,
Just
yes.
asking expectation means the number.
Yeah, the expected value for number of trials, expected number of trials you require to unlock the key. Okay, so you don't have to do those things.
Okay.
Okay, so if you want, how is it 1 by 21? So simply it is, so you can see X is taking values 1 to up to 21. So each of these values should be same. Suppose it is equal to some value A. Okay, all these values are equal to A. Okay, now by using the property of PMF, that summation of these values, okay, summation of these values should be equal to 1, which means A plus A plus A 21 times. How many A's are there? 21A. Okay, so in this way, the value of A will be equal to 1 upon 21.
Okay.
Okay, or simply you can directly see that you have 21 different values. So it is 1 upon 21.
Yes, got it.
Yeah. Okay. Yeah, so the answer is 11 here. Okay, expected number of trials will be 11. Okay. Then the next question is, John parked his car among 10 cars in a row in a mall parking, not at either end. Okay, which has a capacity of 11 cars. In how many ways is it possible that on his return from the mall, he finds that exactly 5 of the 11 places are still occupied? And this 5 includes his car also. If both the neighboring parking slots around his car are empty. Okay, so first understand what are the conditions given in the question. So first of all, the capacity of the parking is 11 cars. Okay, it can consist of 11 cars only. And then the John is not parking the car on the either end. Suppose so, suppose these are the 11 places. Okay, these I have drawn the 11 lines. So this is first, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11. Okay, suppose this is a row where 11 cars can be parked. Now the condition is that John will not park the car on the either end. So which means this position and this one. At these two positions, he will not park his car. Okay, is this clear up to this point?
Yes, ma'am.
Yes, ma'am.
Okay. Next is that in how many ways is it possible that on his return from the mall? Okay, so when he is returning from the mall, he finds that exactly 5 places out of the 11 places are occupied. Okay, and those 5 includes his car also. And the other thing is if both the neighboring parking slots around his car are empty. So which means that
Ma'am, I have a doubt that in this, like in the first statement, it is mentioned that he parked his car among 10 cars. So his car will be 11th, right? Or it will, you're right.
yes.
Okay, ma'am.
Like total, yeah, the thing is that total 11 cars can be parked. Okay, and one car belongs to him. Okay. Okay, so one condition is that he will not park his car either like on both the ends. And the next condition is that returns, he finds total of 5 cars. Total of 5, which means one car will be his car. Okay, so apart from his car, 4 cars will be there. which are parked. Okay. Other condition is that this condition that both the neighboring parking slots around his car are empty. The meaning of this line is, suppose he's parking his car here. Okay. Then these two places, okay, this one and this one will be empty when he returns. Okay. If suppose this is one condition, suppose, or maybe he's parking his car here, then it will be that the fourth and sixth position will be empty. Okay. And the other four cars would be somewhere else. Okay. But not in these two places. Is this thing clear to everyone? What the line, last line says?
Yes.
Yes, ma'am.
Okay. So this is the thing. Okay. So now the main thing is, the question here is, in how many ways is it possible that these places are occupied? So we have to fill the places out of these 11 places. Okay. So now suppose if he is parking his car here, then these two places will be empty. So from the remaining places, okay, just discard these three places. The other four car will be parked on the remaining places, right? Yes, no?
Yes, ma'am.
Okay. You can take this J anywhere. Okay. You can suppose if it is here, then these two places will be empty. Okay. So the other four cars will be parked on the places other than these three places. Okay.
Ma'am,
So
it is fixed permutations like.
yeah, I will explain the question first, then you can ask your doubt. Okay.
Ma'am, first and 11 places are blank.
Sorry.
Ma'am, the
These
first and the 11th place.
no. The John will not park his car. Other cars can be parked here.
Okay, ma'am. Okay,
Okay.
understood.
Yeah. Only John's car will not be there. Okay. So this is one condition. So John will not be parking his car here, because if he, yeah, so yeah, he is not parking his car on the ends. So, and the other condition is that the neighboring two positions will also be blank. Okay. The remaining four cars will not be parked, okay, to the neighborings of his car. So actually what we have to do, we are left with the 11 places. Oh, sorry, 11 minus 3 places in total, right? Okay, where the four cars will be parked. Yes, no?
Yes, ma'am.
Okay. Total 5 cars are there. When he returns, he gets 5 cars, out of which one car is his car. Okay, one car is John's car. So the remaining 4 cars are there. So what we have to do, from the 8 places, we have to put the 4 cars. Okay, and we just have to fill the places. Okay, so which means we just have to select the places out of these 8 places. Okay, and we are not wondering here about the arrangement of the cars. Are you getting my point? So
Yes,
Ma'am,
8C4 should
arrangement
be
is
the
not
answer.
necessary.
Yes,
We just
arrangement
need to
of the
know which
cars.
slots are occupied. That's it.
Yes. Yeah. We just have to fill the places. You can see that in how
Ma'am,
many
is it,
ways.
ma'am, is it because we are not considering the car to be like distinct car? We are just considering John's car and other cars. Is it because of that we are not considering the arrangement?
No, see the
We
question
want to know the
asked
slots
here
that are
is that in,
occupied, not the cards.
yes, in how many ways the 11 places are occupied. Okay.
Okay.
So how we are going to occupy the slots here? Okay. This is the only thing. So suppose I will just give you one situation. So AC4 is the answer.
yes.
11. Okay. So these are the 11 places. Okay. Suppose John is parking his car at this place. Okay. These two places will be empty. Okay. Now we have to put the four cars. Suppose the cars are A, B, C, and D. Okay. I'm just randomly putting the cars. Okay. Other 4 cars can be placed anywhere. Okay. This is one situation. Okay. Again, And now I am placing the card like this. Okay, so you can see that in both the cases, this is the second position, this is the 11th, okay, 10th, this is 8th. Okay, so you can see that these four positions are occupied. Okay, these two will be considered as same, because we are not taking care of this thing, whether car A is parked here or whether car B is parked here. We just have to see like in how many ways we can occupy the four places.
Okay, so whichever position that matters here, the car that doesn't matter. That is why order doesn't
Yes,
matter
yes.
here.
Yeah, arrangement of the car does not matter. We just have to occupy the positions. Okay.
And we just choose
So,
that, and that just remains whichever car we park.
yes. Okay, so in this way, you just have to select four places out of the 8 places. And how this 4 and 8 comes, that is clear, because if John is parking his car somewhere, that the neighboring 2 positions will be empty. So we can exclude these 3 positions. Okay, so from 11 minus 3, which is 8. So from in the remaining 8 positions, we have to fill the 4 cars. Okay, now is it clear?
Yeah, I have a
That's
doubt.
why.
Ma'am,
Yeah,
in this, shouldn't we also choose the position where the John will be parking the car?
and my doubt is that how we identify that this is a case of permutation or it is a case of combination.
Okay, that depends on what is asked in the question.
So, for example, this question, how we identify that this is a case of combination.
Yeah, so in this question, you can see it is asking, in how many ways is it possible that on his return of the car, on his return from the mall, he finds exactly 5 out of the 11 places are occupied. So the meaning of this line is, in how many ways you can fill these 5 cars into the 11 places. Okay, we are not uh, like taking care of the arrangement of the car. Okay, that's what I told here in this figure. Okay, you can arrange the card in this way, A, B, C, D, or maybe you can arrange the card like this. At the second position, you are parking this car B, and like this, the remaining cars. But you can see what positions are occupied: second, 8th, 10th, and 11th. Okay, in both the cases, this thing is same, and we have to find this thing only. In how many ways you can select the positions to be filled. Okay, this arrangement does not matter here. Okay, that you have to decide from the question, what is asked in the question. We just have to occupy 5 places out of the 11. Okay, based on the given conditions.
Okay, ma'am. Thank you.
Yes.
Ma'am, I have a question that how we ensure that he's not parking in the first and the last position in this case.
Yeah, that's why we
This is
have
given. This is given.
No, but in our combinations, how we are ensuring that?
Yes, ma'am. Shouldn't we consider the position where the John is also parking the car, like 9 choose 1? Because we will ignore the first and the last position. Shouldn't we include that in this too, so that we make sure that the first and last position is not parked by John?
By considering the 3 places as well. There's a single
In
element.
this
2,
unit,
3,
the
4.
first and the last position is empty when we are selecting 3, and John is in the middle. So wherever we place this unit, it will be empty only.
See, we
Okay,
are
understood.
excluding
Yeah,
these two because
understood.
if you
Because we are ensuring that first, like if John is in second, then also the first one will be empty, and if John
yes,
is
yes,
at 10th, then 11th will be empty.
yes, yes.
So we are considering John and the two empty places as one unit there.
Yeah, not one unit, but you can see that we are rejecting these three positions, right? We are reducing the number of places here.
Okay. Okay, ma'am.
Yeah.
Thank you.
Yeah, so that's why from 11 minus 3 we have to take. Okay. Now is this clear to everyone?
Yes, ma'am.
Okay. Okay, you can solve this 8C4. What will be the value of it?
20.
70.
70. Okay. Okay, then the next question is two players, Sam and Nina, throw a pair of dice alternatively and independently. Okay. Sam wins if he throws a sum of 6 points before Nina throws a sum of 7 points. Okay. While Nina wins if she throws a sum of 7 points before Sam throws a sum of 6 points. Okay. So if Nina begins the game, then what is the probability of Nina winning the game? Okay. So just read this question again, understand the question well. Two pairs are there, Sam and Nina. And they are throwing a pair of dice alternatively and independently. Okay. So the condition for winning of Sam and Nina, both the conditions are given. So we have to find the probability for winning of Nina. Okay. If she is beginning the game. So which means at the first trial, okay, she will start the game. Okay, she will throw two dice at the first trial. And then at the second
Ma'am,
trial, Sam will.
is this the case of hypergeometric distribution?
Hypergeometric, I don't think we use hypergeometric here. We don't need to use hypergeometric. It's a simple probability question.
Okay, ma'am.
Okay. So, okay, so suppose so when Sam is winning the game, when he gets a sum of 6 points, six, yeah. So I'm taking this S as sum of 6 point. And N is for Nina, and she is winning the game when she gets a sum of 7 point. Okay, you can see in the question. Okay, so Nina wins the game if she throws a sum of 7 points. Okay, you can take any variable, as I have taken S and N here. Now, when you can get the sum of 6, sum as 6, 1 comma 5, 2 comma 4, 3 comma 3, 4 comma 2, and then 5 comma 1. Is it correct? Okay, these are the favorable cases when you get the summation as 6. Okay, and then N is for summation of 7. So 7 you will get when it is 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 3, and 5 comma 2, and 6 comma 1. Is this clear to everyone up to this point?
Yes, ma'am.
Okay, so S, yeah, so S is representing the event when you get the sum as 6 point. N is representing the event when you get the summation as 7 point. Okay. Now, what will be the probability of S here?
5 upon 36.
5 by 36. And this?
6 upon 36.
Can I see the question for a minute?
Have you seen it? Okay. So what will be the probability for S complement? 1 minus 5 by 36?
Yes, ma'am.
Okay, so this will be 31 divided by 36. Okay. Similarly, probability of N complement. Okay. That should be 1 minus 6 by 36, which will be 30 by 36. Okay. Now, the question is, if Nina begins the game, then what is the probability of Nina winning the game? Okay. So, Nina is beginning the game. She is starting the game. Okay, so if Nina begins the game, okay, then what will be the cases in which she can win the game? Okay, then the cases in which she can win. Okay, so if she is beginning the game, so maybe at the first trial he's winning the game. Okay, or maybe at the third trial. Okay, or maybe at the fifth. Okay, so in this way you can see on all the odd number of trials. Okay, then in this like in those positions, in those trial only she can win the game if she is starting the game. Do you all agree with this point or no?
Yes, ma'am.
Okay,
Yes, ma'am.
so first case can be that Nina wins the game in the first throw. Okay, now we have to find the probability of this thing. Okay, so Nina wins the game in the first throw. So tell me what should be this probability? So Nina is winning the game if she throws a sum of 7 point, okay, before the sum of 6 point for Sam. So which means that if she gets a sum of 7 points, okay, she will win the game. Okay, because she is starting the game at the first trial. Okay, so this
Yes,
should
ma'am.
be probability of N, right?
6
N is
by
what?
36.
Summation of 7 point. So it is 6 by 36. Okay, this is one condition. Now the other condition can be, so Nina wins the game at the third throw. Okay, because second throw will be for Sam, right? So she cannot win at the second throw. Is this thing clear to everyone?
Yes,
Yes, ma'am.
ma'am.
Because this condition is given in the question that she is starting the game. Okay, so this probability. So when she will win the game in the third throw, what should be the scenario in that case? What will happen in the first and second throw in
Nina
that case?
loses, Sam loses, and Nina wins.
Yes. So Nina should lose the game in the first trial, which means N complement, right? And that Sam should not get the sum of 6 at the second trial, which means S complement, right? S complement. And then at the third throw, Nina should win. That the sum of 7 should come, which is represented by N here. So do you all agree with this thing, with this line?
Yes, ma'am.
Yes,
No,
ma'am.
ma'am, I didn't like NC. I didn't understand that.
Okay.
And complement.
Okay. See, first of all, you understand when Nina and Sam are winning the game. Okay. So for Nina to win the game is that she should get a sum of 7. So sum of
Yes, ma'am.
7 is represented by N. Okay.
Six.
And
Yeah,
Sam will
6.
win. Yeah, Sam will win if he gets the summation of 6, which is represented by S. Okay. So Nina is winning in the third trial, which means in the first trial, first throw, Nina should not win.
And
Which
lose.
means the Yeah, summation of 7 will not come, which means n complement.
Ma'am, how we decide that if she can't win in the first trial?
Yeah, we are just taking the cases. We are not deciding it. We are just taking the cases here. Okay, what can be the possible ways in which she can win? Okay, this is not
Okay.
the final answer. Yeah.
Okay.
Yeah, it's not the final answer. Okay, so the next will be that Sam is not winning the game in the second trial, which means the summation of 6 will not come. So which means its complement will come. Okay, and then Nina will win in the third, which means the summation of 7 should come, which is n. Okay, that's how I have written this thing. Okay, and intersection, which means like all these things should happen, right? That's why intersection is there, like and condition is there. Okay, and now in the question it is given that they are playing
Ma'am,
independently.
if she wins that, then n should become, right? So why we are taking n complement?
And complement is for the first row.
Okay.
Okay, we have to take the result of the first and second row as well, right?
Okay, got it.
Yeah. So it is given that they are playing it independently. Okay. So the outcome of the first row will not affect the outcome of the second row. Okay. So now, since all these events are independent, we can write it as probability of n complement into probability of s complement into probability of n. Okay, now is this thing clear? And now we know the values of these things. So probability of n complement is 30 by 36. Okay, and then probability of s complement is 31 by 36. And then probability of n is 30, sorry, it is 6 by 36.
6 by 36. It is 1 by 6.
Yes, yes, you can write that also. Okay. Okay, so this was the second case. Next can be that she will win in the fifth throw. Okay, so I'm writing for that case as well. So Nina wins the game in the fifth throw. Okay, so as we have written this line, in the same way we can write this probability. Okay, so Nina is winning the game in the fifth throw, which means in the first throw Nina is not winning, and second throw Sam is not winning. In the third throw Nina is not winning. Okay, and then in the fourth Sam is not winning, and then in the fifth throw Nina is winning. Is this clear?
Yes, ma'am.
And they all are independent, so again we can write it in the multiplication of in each individual. And this is 6 by 36. Okay, so now we just have to identify the pattern. So we all know that Nina, if she is starting the game, she can either win in the first row or in the third row or in the fifth or in the seventh, okay, or in the ninth and so on.
Forming a GP.
Yes, okay. So now what we have to do? So the final probability, so probability, so probability of Nina winning the game. So what we will do now? We have to add the probability for all the cases, right? Okay, either she will win in the first row or in the third row or in the fifth or in the seventh or in the ninth, like this. So basically we have to add these probabilities. So I have written 3 cases. Okay. By following the same pattern, I will write the remaining cases also. So you can see the first case, the value is 6 by 36. This is 6 by 36. Next, in the second case, if she is winning in the third throw, the probability is this one. So which is 30 by 36, 31 by 36 into 6 by 36. Okay. Next is this thing. Nina wins the game in the fifth throw. So you can see that this is. May I write it like this? 30 by 36 into 31 by 36 whole square into 6 by 36. May I write like this?
Yes, ma'am.
Okay. Now tell me what will be the probability if she wins the game in the seventh throw?
8 to the power n minus 2 into
Q.
6. 30 upon 36
30 by
into
36.
31 upon 36 is to the power 3 into 6 upon 36.
Yes, so it will become cube of it. Okay. So similarly, you can see a pattern here. So here it was like this term power 0, here this term power 1. Okay. And here power 2. And if you take 7th trial, this will become power 3. Okay. In this way, the power of this term will increase. Is this thing clear?
Yes, ma'am.
Okay. So we just have to add this thing. So it is cube. Here it was the square of this term. Next will be 30 by 36. This will be cube, and then 6 by 36. Okay. And so on. In this way, you can write all the terms. So, okay. Now we have to add these terms. Okay. So from each term, I can take 6 by 36 as common. Okay. Then it will be 1 plus 30 by 36, 31 by 36. Okay. Then this one. Okay. Then it will be cube of it. Okay. And so on. So now you can see that it is a infinite terms geometric series. Yes, no?
Yes, ma'am.
Yes, ma'am.
Okay. So what will be the summation of this series?
A divided by 1 minus r.
Yes. So we have 6 by 36. And then the summation of this is A upon 1 minus R. What is A here?
1.
6 upon 36. Oh, sorry, 1.
So A will be 1 because this thing I have taken as common. Okay. So A is 1. A is the first term of the
I
series,
doubt
which is
this. How
Hmm.
how we got this one?
we have taken the common.
We
We have
have
taken
taken 6 upon 36 common, right?
yes, yes.
So why how it is 1?
We are considering the series inside the bracket.
Which one? You are
Okay.
asking about this one?
And the first one which you have written that in that 6
This
upon 36, yeah. Yeah.
this one. Okay, yeah. So that this is like if you take common 6 by 36 from the entire, here you will be left with 1 only, right? Just look at these steps carefully. Is it clear to you now or not? This one has come because we have taken 6 by 36 as common. There is no more term here. Okay,
Okay.
or if you're not able to understand, if you just multiply this inside this bracket. If you multiply, you will get first term as 6 by 36.
Okay, okay.
Second term as this one. Okay, yeah. And now this is the infinite terms geometric series. The summation of this, I'm just writing in short. Okay, S infinity is A upon 1 minus R. Okay, so A is the first term. Okay, and R is the common ratio. Okay, So you just look at inside the bracket only. Okay, inside bracket it is forming a geometric series. So the first term is 1. Okay, what is r here?
136 into 31 upon
30 upon 36 into 31 by 36. Okay, this is the r here, common ratio. Is this clear to everyone? How we get the value of r?
Yes.
So
Okay, now you just solve this part and you will get the final answer. Just solve and tell me what is the value of this thing.
I got 0.59 and more decimals.
Okay. Yeah, it is coming out to be 0.59 something.
Yes, ma'am.
Yes,
Okay, yeah, so this should be the answer. Yes, you can see it is coming in the range. Okay, is this question clear to everyone?
yes, ma'am.
Yes, ma'am.
Okay, then. Okay, then the next question number 10 is, suppose that the random variable x assumes 3 values 0, 1 and 2 with probabilities this respectively. Calculate the value of f1. What is this f1?
Cumulative distribution function.
Yes, it is the CDF. Okay, cumulative distribution function. So the distribution of x is
Ma'am,
given.
yeah, I have the doubt regarding this question that there is a probability whether Nina wins or whether Nina not wins, and the event is independent also. So why we can't use any like distribution here?
Okay, which distribution you want to take?
I think hypergeometric or yeah.
Okay, so how will you solve the question then?
Then the formula is MCI into 1 minus P and minus I. Yeah, MCI, yeah.
Okay, try solving the question in that way you are taking and see if you're getting the same answer or not. Because this is a simple probability question. I didn't think that we need to use that thing here. Okay, let's try. Test and trial that thing. If it works or not.
Ma'am, we don't know about the population. Means how many trials are we going to assume for the M?
Yes, that is
Because
infinity.
she can win at any number of at any place, either at 1, either at 100, either at 500.
Yes. We don't have that. If you know the hypergeometric, it is capital and small and M, right? So how will you fit these things here? We are not like taking
Don't
any
have finite
samples or
values.
yes. Okay, so how will you fit that distribution here?
Ma'am, because it is given that we are taking the exactly how in how many trials that Nina wins, so we can calculate. I think, but
Okay, again I will say that test and trial this thing if you are thinking like that. Okay.
okay, ma'am.
Okay, so the question number 10 is, x is taking values 0, 1 and 2. The probabilities are 1 by 3, 1 by 6 and 1 by 2. Okay, we have to find f1. Okay, so f1, this is the CDF. So f1, this is something we can write it as probability x is less than or equal to 1. Okay, which means we have to add the probability at 0 and the probability at 1. Yes or no?
Yes, ma'am.
Yes, ma'am.
So probability at 0 is 1 by 3. Probability at 1 is 1 by 6. Okay. So simply it will be 3 by 6, which is 1 by 2, 0.5. Okay, this is the simple question. I hope it is clear to everyone.
Yes, ma'am.
Yes, ma'am.
Just have to use the formula of CDF and some properties of it. And you can easily solve this question. Okay, the next question is x follows exponential lambda, then find the value of z such that probability x greater than or equal to 100 given that x greater than or equal to 50 is equal to probability of x greater than or equal to z. So this thing is given, distribution of x is given, we have to find the value of this z. So simply we just have to use the PMF of exponential, PDF of exponential, okay, and the conditional probability formula, and then we can find the value of z. So here x is following exponential with parameter lambda. So what is the PDF of x here? What will be that?
One minus e power minus lambda.
Lambda into e raised to power minus lambda x. PDF.
Lambda to the power minus lambda x. Okay, this is the PDF of exponential distribution. Okay, now the condition was x is greater than or equal to 100, given that x greater than or equal to 50. Okay, this is given to us. Now just use the formula and find the value of z. Okay, so first of all, it will be x greater than or equal to 100, intersection x greater than or equal to 50. Okay, what will be here?
X greater than equal to
X greater than equal to
Greater than equal to 50.
Now what will be the intersection part of this?
X greater than equal to
Greater
100.
than 50.
It will be x greater than or equal to 100. Okay. So how the intersection part is x greater than or equal to 100, you can just draw a real line. Suppose this is 50 and this is 100. Okay. So x greater than or equal to 50, which means we can represent it with this line. Okay.
Yes, ma'am.
And then x
Got it.
greater than or equal to 100 with this line. So you can see which is the overlapping part of it. Okay, which is a common part. X
Greater
greater
than
than or equal to 100. Okay. Yeah. So now for solving this part, we have two ways. Either you can you find these probability by using the PDF method, you can integrate it. Okay. Or if you remember the CDF formula for exponential distribution, then you can directly use that. Okay. So what is the CDF for exponential distribution? Anyone remembers it?
1 minus e raised to minus
Minus lambda.
x.
So CDF of exponential distribution, suppose you have to find it at some point e, then it is equal to 1 minus e to the power minus lambda a. Okay, so we can use this formula here directly. So this line we can write it as 1 minus probability x less than 100. Okay, and then 1 minus probability x less than 50. Okay, this also we can write it as 1 minus probability x less than z. Is this part clear to everyone? Okay, now this is the CDF, right? Yes, no?
Yes, ma'am.
Okay, now just use the formula. So what is the value of A here, this A in this part?
100.
100.
Yeah, 100. So this will be 1 minus e to the power minus 100 into 100 into what?
Lambda.
Lambda. Okay. This will be 1 minus e to the power minus 50 lambda. This will be 1 minus e to the power minus z lambda. Okay. Now just solve it. So this 1 will be cancelled out and this minus will become plus. And this will be e to the power minus z lambda. So if you solve it, this will be e
100
to the
lambda.
power minus 50
100
lambda.
lambda plus. Yeah.
Yeah, you can solve, you just solve this thing. Okay. So now tell me what will be the value of z here?
50.
50. Okay, we can compare these two things. And the value of z will be 50. Okay, anyone has any doubts?
And can you repeat? You
Okay, which part?
last where you took the
Ma'am, why did
CDF
you not
formula.
convert it into z value? X minus nu by sigma, that az value.
X minus mu by sigma. So why we will do? We are not having a normal distribution here.
Yeah, this is exponential. That
Okay,
is
this
for
is
normal.
exponential distribution, and we already know the PDF of exponential distribution that we can use here. Okay, we don't need to use normal distribution here.
Okay, ma'am, got it.
Yeah. Yeah. What about the other one? Which part you want me to repeat?
No, ma'am. I got
Okay.
it.
Okay. Anyone else has any doubt? Okay, then we solve the next question. So question number 12. According to a survey, the time taken by teenagers to finish a box of donuts is uniformly distributed between 1 to 6 minutes. So a cafe in New Delhi used this data for its advertisement that challenges teenagers to finish a box of donuts within 100 seconds to win a grand prize. A teenager, Ajay, accepted the cafe's challenge. What is the probability that he will finish the box of donuts within 4 minutes, given that he lost the challenge? So just read the last line. Tell me what probability we have to calculate here. If I am taking the random variable as x, okay. So suppose x is some random variable which is represented the time, okay, taken by a teenager. Okay, to finish a box of donut. Okay. So also it is given that x is following uniform. Okay. And the interval is 1 to 6. Okay. Now tell me what we have to find here mathematically.
Probability of x is less than 4 given
When
x
one
is
minus
greater than 100 seconds.
Yes. So we have to find that probability x is less than 4. Okay. So it is written that he will finish the box of donuts within 4 minutes, which means x is less than 4. Okay. Given that he lost the challenge. Okay. So when he will lost, yeah, so he is losing the challenge. So when he will lose the challenge?
X is greater than
Yeah. So
100
if
When
x is
600 seconds.
100
600
so if
seconds.
x is greater than 100 seconds, then he will lose the challenge. So this is given in seconds, this is in minutes. So we will both, we have to convert both the things in the minutes, okay, or maybe in the seconds. Okay, we have to convert it into same units. So 60 seconds.
Take 100 by 60.
Yes. So 100 seconds is equals to 1 minute. Okay. 60 seconds is equals to 1 minute. So 100 seconds will be 1 by 60 into 100. Yes, no?
Yes, ma'am.
So this will be 5 by 3 minutes. Okay. So x less than 4, given that x is greater than 5 by 3 minutes. Okay. You cannot take x greater than 100 here. Okay. Otherwise, it will be wrong. Both the values should have the same unit. Okay. We can convert it into seconds also. Now, this is the conditional probability. So x is greater than 5 by 3 and less than 4, given that x is greater than 5 by 3. Okay, so the distribution of x is given, it is uniform. So we can just find these probabilities. So this thing, I can write it as probability x less than 4 minus probability x less than 5 by 3. Can we write it like this or not?
Yes.
Okay, it is the property. And the denominator, we can write it as 1 minus probability x is less than or equal to 5 by 3. Okay. Anyone has any doubt in this part?
No, ma'am.
Okay, then. So this is what? This is the CDF at 0.4. Okay. And this one is the CDF at 5 by 3. Okay, since it is a uniform continuous distribution. It is a continuous distribution. So if you write equal to sign here or not, that will not matter. Okay, because the probability at a single point is 0. Okay, so we can write this term as the CDF of the variable x. And this is 1 minus the CDF of x again at 5 by 3. Okay, now tell me what is the CDF of continuous uniform distribution?
X minus A upon B minus A.
If
X
x
minus
follows,
A by B minus.
yes, so if x follows uniform with parameters a comma b. Okay, so the CDF is, so if x is less than a, then definitely it will be 0. If x is greater than b, greater than or equal to b, then it will be 1. Okay.
1.
And in these two, it will be x minus a divided by b minus a. Okay. So this is the formula actually, x minus a divided by b minus a. Okay. So you can just write. So CDF at 4. So it will be 4 minus. So what are the values of a and b here?
1 and 6.
1 and 6.
So 4 minus 1 divided by 6 minus 1 minus 5 by 3. So 5 by 3 minus 1 divided by 6 minus 1. Then 1 minus. Solve it. So it will be 7 by 13. Okay. Are you all getting the same value? Yes, no?
Yes, ma'am.
Yes, ma'am.
So you can match the answer. 7 by 13 is the correct answer. Okay. Then the next question is, a company has predicted the next year's profit will follow the probability distribution shown in the table. The random variable X denotes the profit in million rupees. Loss is denoted by negative profit. So this distribution of X is given, but the company cannot retain all the profits to itself since it has to share 15% of the profit to its investors. The amount that the company retains is given by y equals to 0.85x. So what is the approximate standard deviation in million rupees of y? Okay, so tell me, how will you solve this question? What we have to find here first?
Standard deviation.
Yeah, standard deviation of what will you find first?
Of y.
The company's profit.
Yeah.
Find for X.
Yes. So we have to find for x first, and then by using that, we can find the standard deviation of y. Okay. So relation between x and y is given to us. Okay. Now find the standard deviation of x. Okay, which means you have to find the variance of x first. Okay. So variance of x is expectation of x square minus expectation of x whole square. Okay. So find the value of expectation of x and expectation of x square.
Ma'am, we will be using the formula that variance E of x square minus E of x whole square.
Yes.
Okay, ma'am.
So what is the expectation of x coming?
1.15.
1.15.
Now find expectation of x square.
It will be 2.9.
Is it 2.9 for everyone? You all can solve this part? Yes, no?
Yes, ma'am.
Okay, then you can solve it. So variance of x will be expectation of x square minus expectation of x whole square. Just put the values. So 2.9 minus 1.15 whole square.
$1.5775.
Yeah, so if you convert it to two decimal places, it will be 1.58. Okay. Now y is equals to 0.85x. Okay. If you have to find the variance of y, okay, this will be variance of 0.85 times x, which means 0.85 square variance of x. Is it so or not?
Yes, ma'am.
Ma'am, why we are taking the square?
Okay, if you have a constant which is multiplied with x, okay, and you are taking variance of it, so it will get squared. If you remember the properties of variance, variance of ax is equals to A square times variance of X. This is the property of variance. Okay?
Okay, ma'am. Yeah.
Yeah. Okay, now standard deviation of Y is equals to square root of the variance of Y. Okay? So square root of this thing, which means again 0.85. Okay? And square root of variance of X. Okay? So 0.85 into square root of variance of X is 1.58. So this is coming out to be 1.06. Okay? Is this clear to everyone?
Ma'am, I have a doubt, ma'am.
Hmm.
How to find E of x square, ma'am?
Okay. So the formula of E of X square is, I will write it down. So you have to take the square of X values and multiply it with the corresponding probability values. So in the table, you can see the values taken by X is minus 0.5, 0, 1, 2, and 3. Okay. So here it will be minus 0.5 whole square and the corresponding probability 0.2. Okay. And this is
Okay,
0.
ma'am. Okay.
Next is 0 square into 0.15, 1 square into 0.25 plus 2 square 0.2 plus 3 square 0.2, it will be 2.9. Okay.
Okay, ma'am. Thank you.
Okay. Anyone else has any doubts? Okay, then the next question is, the duration of a video game is a random variable with the exponential distribution with mean 20 minutes. Suppose that when you enter a video arcade, two players are playing the game independently. Find the probability that exactly one of the two will be playing for less than 40 minutes. So if I take the variable as X, so X is the duration of the video game. Okay. And X is following exponential distribution. Okay. With mean equals to 20 minutes. Okay. So mean. So what is the mean of the exponential distribution?
1 by lambda.
1 by
1 upon
lambda.
lambda. Okay. So this is given as 20. So the value of lambda will be 1 upon 20. Okay. So lambda is equals to 1 upon 20 here. Okay. Now what will be the probability that X is less than 40? Again, we can use the CDF formula. It will be 1 minus e to the power minus lambda and this value. So lambda is 1 upon 20 and value of A here is 40. Okay. So it is 1 minus e to the power minus 2. Similarly, probability for X greater than or equal to 40. What will be this? 1 minus probability of X is less than 40. Is it correct or not?
Yes, ma'am.
Okay. So this probability will be e to the power minus 2. Okay. Why are we calculating these two? Because it is written in the question that we have to find the probability that exactly one of the two will be playing for less than 40 minutes. Okay, so one pair will be playing for less than 40 and another will be greater than 40. So first of all, we have calculated these two things. Okay, now we have to find the probability that so two players are there. So I am taking that even is some player. Okay, suppose this is player 1. Okay, player 1 is playing for less than 40 minutes. Okay, and E2 is that player number 2. Okay, 2 players are there. So player 2 is playing for less than 40 minutes. Okay, the probability we have to find is probability that exactly one of the 2 players, okay, will be playing for less than 40 minutes. Okay, so we can write it as, so suppose player 1 is playing for less than 40 minutes, which I can write as probability of E1. Okay, so another player 2 will be playing for more than 40 minutes, right? Which I can write as E2 complement. So this is one possibility. Another maybe player 1 is playing for more than 40 minutes, which will be probability of E complement. Okay, and the second player is playing for less than 40 minutes. Are you all able to understand this line?
Yes, ma'am.
Yes, ma'am.
Okay, now we can just put the values. Okay, so probability of E1. So E1 is what? Less than 40 minutes. Less than 40 minutes is what? 1 minus e to the power minus 2. Okay. Okay, then complement, which means x greater than 40, which is e to the power minus 2. Okay. Similarly, even complement. So even complement will be that player 1 is not playing for less than 40 minutes, which means greater than 40 minutes, which is e to the power minus 2. Okay, and this will be 1 minus e to the power minus 2. So this is what? 2 times e to the power minus 2, 1 minus e to the power minus 2. Is it clear to everyone? Anyone has
Yes,
any
ma'am.
doubt?
Clear, ma'am.
Okay. Okay. Okay, then the last 2 questions. So first one, a fruit seller has 6 dozen bananas, out of which 12 are rotted. If a customer wants to purchase some bananas and chooses 6 bananas without replacement, then how many bananas, rotten bananas, can expect customer? Now tell me which distribution are to be used here.
Hypergeometric distribution, I guess.
Yes, here we have to use hypergeometric distribution. Okay. So we have in total 6 dozen of bananas. So 6 dozen, which means 6 into 12. So 6 into 12, which means 72 bananas are here in total. Okay, out of which 12 are rotted. Okay, 12 are rotted. So remaining 72 minus 12, which is 60. Okay, so this will be non-rotted bananas. Okay, now out of these, customer wants to purchase some bananas and chooses 6 bananas without replacement. Okay, so out of these 72 bananas in total, the customer is taking 6 bananas. Okay, so now here I can take that x is the variable which is representing number of rotted bananas selected. Okay, so what we have to find? We have to find the expected number of rotten bananas. Okay, so we have to find the expectation of x. Expectation of x is question mark. Okay, now here what is the value of capital N?
72.
Capital small m and small n. Yeah, so capital N represents the total number of observation in the population. So it is 12. Okay, now what will be m here?
12.
So m will be 12. So m is representing the total number of rotten bananas. Okay, so which is equals to 12. If suppose in the question we are asking about the expected number of non-rotten bananas, okay, then you can take x as number of non-rotten bananas, and this m, small m, will be total number of non-rotten bananas, okay, which will be 60 in that case. Okay, so this variable x and this m you have to choose according to the question, and the n is 6. Okay, expectation of x is n into m divided by capital N. Now just put the values. So this will be 1. Okay, is this question clear?
Clear, ma'am.
Okay, then we solve the last question. The average number of penalties charged by a police in a day for not following the traffic rules is 5. Okay, so average value is given. Assume that the number of penalties charged on different days are independent and follows the Poisson distribution. Find the probability that less than 4 penalties will be charged in a day. So here random variable x, okay, suppose it is representing the number of penalties. Okay, and it is following Poisson distribution with average value 4. So we all know that expected value for a Poisson random variable is equals to lambda. Okay, so this average value is given as 5. We have to find probability x is less than 4. Okay, now what is the probability mass function of Poisson distribution? It is e to the power minus lambda, lambda to the power x divided by x factorial. Okay, now just put the value. So x less than 4, which means x equals to 0 plus x equals to 1 plus x equals to 2 and x equals to 3. Okay, now just put the values and find your answer. So lambda is equals to 5 power 0 divided by 0 factorial, then e to the power minus 5 power 1 divided by 1 factorial. Okay, now I hope you all can solve this calculation part. You can do it on your own. Okay, so if you take e to the power minus 5 as common, you will have 1 plus this will be 5, then 25 by 2, then 125 by 3 into 6. Now just solve this thing.
Approximately 0.264.
Yeah, it is coming out to be 0.006 something. And this is approx 39 point. And when you multiply, it will be 0.27 something. Okay. So the answer is coming in the range. Okay, anyone has any doubt? This was the last question. Anything else? Any doubt?
And sometimes I am unable to comprehend what the question is asking.
Okay, for that you need to do practice.
Ma'am,
Okay,
can you show question number 15 what you did, the solution?
Hello. Sorry, I got disconnected. If you have any doubt, you can ask now.
Ma'am, question number 15, what you did, can you show?
Question number 15.
Yeah, ma'am.
Okay. Yes, so question number 15 was based on the hypergeometric distribution. Okay, so you can see the question. Two scenarios were there. Like in the total population of bananas, some bananas were rotten, okay, and the other will be non-rotten. And we had to find the expected value of rotten bananas selected. Okay, our customer is taking 6 bananas. So out of those 6 bananas, how much, how many you can
Ma'am,
is
you
clear?
are not audible.
Hello, am I not audible now?
Now you are audible. Ma'am.
Hello.
Yes, ma'am.
Yes, am I audible now?
Yes, ma'am.
Yes, anyone has any doubt?
Ma'am, if you can just tell that question number 15, it was direct formula based or not? Because you were disconnected that time.
Okay, okay. Okay, now my screen is visible.
Yes, ma'am.
Okay, yeah. So in the question, the question says that a fruit seller, yeah. So a fruit seller has 6 dozen bananas. Okay. So in total, you can see the total number of items in the population is given, which is 12. Okay. Sorry, which is 6 dozen. So 6 into 12, okay, 72. Out of those 72 bananas, 12 are rotted. Okay. So there is a customer who is purchasing 6 number of bananas. Okay, without replacement. Since it is without replacement, so it is following a hypergeometric distribution. Okay. So it is asking how many rotten bananas can expect customer. So it is actually a direct like formula based question. Now you can see the solution. Okay. So out of the total 72, 12 are rotted and the remaining are non-rotted. And we are selecting 6. Now in the sample, okay, sample of 6 selected bananas, how many can you expect to be rotted? Okay, that was something we have to calculate. Okay, so this way you can find from this formula. Okay, so you can select that random variable x is representing the number of rotten bananas selected in the sample. Okay, in the sample which is n is equals to 6. And this is the formula. Okay, so capital N represents the total number of items in the population. Okay, M is the total number of items in that category, which is the rotten bananas here. Okay, and now
Okay, ma'am, got
small
it.
n is the sample size which you are taking. Okay.
Yeah, ma'am, understood, ma'am. Thank you, ma'am.
Okay, anyone else has any doubt? If no one has any doubt, then we can end the class.
Ma'am, anything more we have to practice for the intern? Like for this mock test, we have to revise or anything else? If you can just say.
You have to revise all the syllabus like from 1 to 12, but you have to focus main on the content of week 9 to 12 because that will cover the 60% of the questions. Okay.
Okay, ma'am.
From
Yes, ma'am.
week 1 to 8, you can revise the basics of the topics first, and then if you have time, you can go to the next thing. Okay. But
Got it,
prepare
ma'am.
9 to 12 well. Yeah,
Okay,
okay.
ma'am.
Yeah, prepare for exams. Best of luck for everyone.
Thank you, ma'am.
Thank
Okay,
you,
yeah.
ma'am.
Thank you, everyone. Yeah. Good night. You all can leave the class.